Hi, and welcome to Got Science. I'm Mike Zell. Before you got here, I was planning a canoeing trip. The problem is, I really like hot food, but we'll be traveling about 25 miles a day and we can't spend a lot of time cooking or setting up camp.
Excuse me, Mike. I don't mean to be a nosy Parker, but I couldn't help overhearing. Can I be of assistance?
That's Sim, the Got Science simulator. Probably not Sim, unless you can magically heat food without a flame.
No problem, Mike.
What's this?
Barbecue beef and potatoes, and it heats up without a flame, but there's nothing magic about it. The process used is called an exothermic reaction.
What?
That's exothermic, Mike. It's a type of chemical reaction that releases heat. Would you like a demonstration?
I'm ready when you are.
Exothermic reactions are a big part of your daily life. For example, you may burn methane or propane to heat your home. And some of your electricity is probably generated through the burning of coal. These are both common exothermic reactions. Some substances can create this type of reaction without a flame, like your camping meal. It uses salt water to trigger an exothermic reaction in the cooking pouch. At 30 seconds, you can see that the temperature has already reached 55 degrees Celsius, and hydrogen is bubbling out. I'm using time-lapse here to move through the reaction quickly. I've also placed the cooking pouch in a tempered baking dish for safety. Normally, this reaction occurs inside of the cardboard packaging. At 1 minute 15 seconds, the temperature has jumped to 98 degrees Celsius, and steam is being released at the top. This particular reaction involves the oxidation of magnesium. And believe it or not, what's happening inside that pouch is similar to the process that causes iron to rust.
And that gives me hot food with no flame?
That's right, Mike. But there's more, of course.
Of course.
We should also talk about endothermic reactions, which produce an opposite effect and actually absorb heat.
Can you give me an example?
I was hoping you'd say that. Endothermic reactions are not as common as exothermic reactions, and all chemical reactions are either endothermic or exothermic. Here's an endothermic reaction that I think you'll find fascinating. First, we'll mix together some barium hydroxide and ammonium chloride in a beaker. Notice that when combined, these two powdery substances create a slushy, snow cone consistency. That's because water is produced during the reaction. At just 30 seconds, the temperature has already dropped to 11 degrees Celsius. Now let's have some real fun. We'll place a few drops of water on this ordinary piece of wood and put the beaker on top. What do you think will happen?
Well, if it gets cold enough, I guess the beaker could freeze to the wood. Is that even possible? Glass to wood?
Let's test your hypothesis with the help of some time-lapse. The temperature is now below zero and still going down. At 2 minutes 15 seconds, we've reached a chilly minus 28 degrees Celsius. And sure enough, the beaker is firmly frozen to the wood.
It's pretty amazing, Sim. I don't know where you get this stuff.
Just doing my job, Mike. Have fun on your camping trip. And bon appetit.
Thanks, Sim. And thank you for joining us today. For Got Science, I'm Mike Zell. We'll see you next time.